Rewrite the quadratic in the form y equals a times x minus h squared plus k. Find the vertex, the range, and the zeros of the function. Graph the function. So if you want to try and write it in this form with an exponent 2 on the outside, we're going to first have to move this constant to the other side of the equation. Y minus 1 is equal to negative 4x squared plus 8x. Then the next thing is to try and get this a out in front of the parentheses. So you're not factoring out what's common, you're just taking this leading coefficient, negative 4, and factoring that out of the expression. So when you factor the negative 4 out from a positive 8x, that leaves you with a negative 2x. Double check, negative 4 times negative 2x is in fact positive 8x. Now this next step is to take half of the coefficient inside with the x. So when we take half of negative 2, we get negative 1. We don't bring down the x because what's happening is we're taking that exponent and putting it on the outside. So that if I was to multiply this all the way out, x minus 1 squared, I would get x squared minus 2x plus 1. So this negative 1 squared is new to the equation, and we are no longer balanced. We multiply this negative 1 squared times the negative 4, and then we add that result to the other side of the equation, which is negative 4. Negative 1 squared is positive 1. Positive 1 times negative 4 is negative 4. So we're not quite in the right form yet. We wanted the a out in front, which we have, and the exponent out, which we have, but we should put the constant back on this side of the equation with the x. So we add 5 to both sides of the equation. So now that we have this quadratic in the correct form for graphing a parabola, we can read off the vertex, which happens to be the number inside with x is the x-coordinate, except for we need to use the opposite. If it says negative 1, we use positive 1. And the number on the outside is the y-coordinate. So at positive 1, positive 5, we have our vertex. Now this parabola is headed down because our leading coefficient is negative. So this parabola is going to open down. They want the range. Well, if we're going to open down, it means that we're going to be going down from here. So our range will start at 5, positive, and go all the way, oops. Our range is the lowest point to the highest point, and the highest point is 5. So we put that in the back with a bracket. It's included because we really get to that point. And our range, how low does it go? Well, it's going down forever. So that's to minus infinity. So we found our vertex, we found our range, the zeros. Well, let's come back to that in just a second. Let's finish graphing this first. To graph this function, we can plot points. So we can go on either side of this one and come up with a couple of new good points that'll work. Let's put this 0, actually let's put this 0 back into the original equation. 0 squared is 0 times negative 4 is 0 plus 8 times 0 is 0, add 1 is 1. So we have another point at 0, 1, way down here. And because all parabolas have symmetry, if you go the same distance on both sides of the vertex, you'll end up with the same y-coordinate. So this parabola is a little bit thinner than most other parabolas, and it's headed down, it opens down. So how are we going to find the zeros? Well, let's go back to this equation right in here. Y minus 5 is equal to negative 4 times x minus 1 squared. I'm going to this equation because if I'm trying to find where it crosses the x-axis, my y value is 0. So if the y value is 0, then I don't even have this here in the equation. So to solve this equation for x, the furthest thing first, we'll get rid of that negative 4, and since I'm running out of room, I'm still going to multiply by the reciprocal, which is a negative 1/4. This is all one term because it's all held together with multiplication, so I only need to write this negative 1/4 once. And I'm not going to use the distributive property, I'm just simply going to multiply the negative 1/4 to the negative 4. Since it's all one term, I multiply it to one thing, not the distributive property. So on this side of the equation, we have positive 5 over 4 is equal to, and on this side of the equation, we have our x minus 1, the quantity squared. So our next step would be to try and get x alone to take the square root of both sides of the equation. And when you take the square root, you write plus or minus. So the square root of 5 I still don't know, but the square root of 4 is 2, is equal to x minus 1. So now we need to get x alone. We can add 1 to both sides of the equation. Now this 1 is a whole number, and this is a fraction. So So if we want to write this together as one answer, we need to change this 1 into a fraction, something like 2 over 2. 1 plus or minus the square root of 5 over 2, or we could write 2 plus or minus the square root of 5 all over 2 is equal to x, which makes it our zeros. It says that our y value, remember we let y be 0, so when they ask you for zeros, they're asking you where it's crossing the x-axis, the y value is 0. We have 2 plus the square root of 5 all over 2, and we have 2 minus the square root of 5 all over 2. And if you want to write it as a 1 plus and minus this fraction, that would be fine.